Hey, hi everyone. So today we are back with our new video on our channel, which is on Model Context Protocol. So I think many of you might have heard about it, or some of you may not have heard about it as well. So we're gonna deep dive into this specific video about this technology, how it works, and how it actually can be used in different use cases also. And at the same time, we will deep dive into one of the architecture also, how it looks like. So this is a new playlist that we are bringing in where we'll be talking about the MCP and A2A protocols also going forward, and other relevant protocols also that will help you in your Gen AI journey as well. So in this playlist, we're gonna break everything from the basic concept, how it works, and then we'll go into deep dive into how it works on the low level with respect to specific use cases also. So this is about this playlist and how this playlist is gonna be structured. And this is the first video of this entire playlist. So I hope you will enjoy it and I hope you will learn something new out of it. And at the same time, we will publish some articles also on our blogs that we have on different portals. So, for which we will add links in our description so that you can go there and browse it and get some more information on this technology and other relevant technologies also, for which we are publishing the articles over there. So, I think let's get started with the topic for today. So I welcome you all for today's video. So today's we are talking about MCP servers or what is MCP clients and all. So first of all, we will discuss about what is a problem statement and why. Then we'll go to the area that why MCP are a solution. So let's think of you have an AI model which you are trying to interact and get the information out of it. Yeah. So in that AI model, you want to give some information to it, or if you don't give the information to AI model, it will give you the answer based on how it is trained and based on what is your query as well. So let's deep dive into it how you can make the LLM a bit more powerful by using MCPs and how actually MCPs complement LLMs to make it more powerful and give more answers or give answers in the more meaningful way and in more correct way as well. To avoid hallucinations also you can talk about. Now the problem statement. Different large language models that we have from different providers like Claude and OpenAI and Google. So all of them are powerful, uh, but inherently they need some kind of external knowledge to understand more and give you the better answer. Now, all of these models have a knowledge cutoff date. For example, if a model is released today, so then that model will have a knowledge which is till the date it has been trained on. So, let's say if the model is released today, and if the cutoff date is today, or let's say the yesterday, so then after the events that happen post that, then it will not have an idea about those when that LLM model is answering your questions. So that's where you would need some kind of information that you want to give to LLM because LLM is generating text for you. So if you give the more information or more context about the future informations or future knowledge also, so then it will be able to correlate to it much better and it will be able to get the information out of it and give you the relevant answer. That's how the AI models will actually help you. Now, to give the information, we have used different techniques when we are working with the RAG models and all that. So you can have your own knowledge base, and whenever you are trying to give a query to LLM model, you can create a RAG pipeline and get the data out of your data sources and then send that data to the LLM models. But now there is another technique. You have different interfacing systems. Okay, you have your APIs, you have your database, you have your external systems, you have your external connectivity systems which are outside your boundaries and all that. But you want to get data out of it as well. And when you talk of RAG, you may not have that entire data available in your data stores, but whatever is available in your data store, that only you can send to the LLM models. But with this, you can connect to those external APIs, and then all the connections will be maintained via one separate via one connectivity layer only, and you need not to build separate integrations for each of those connections. So let's say for APIs, you need not to build separate connections for each of the APIs. You will have one server or one MCP server which can give you the entire information of all the APIs, and that LLM can decide which API to call. And then same way, if you have another external systems, you can have the information of all those external systems in the MCP servers, and your MCP client can actually get that information and send to LLM, and LLM can let you know which one to call and which one not. So this is actually the overall picture why MCP servers are required and what problems they solve and how they solve. Let's move ahead. Now, what is their architecture? Now, we have taken a typical use case where we talk about a host application. Host is nothing but a application where your MCP client is running. So now host you can consider a software kind of thing which is installed on your desktop or on any of your OS platforms. For example, if you use different tools for development, let's say VS Code, which is written here, or let's say Cloud Desktop, or any other IntelliJ or any other JetBrains kind of tool. So you use that. That is your host. Inside that, if you have a MCP client, which is installed with any of the extension, for example. So let's say you install an extension of GitHub Copilot. Okay, so that extension may have an MCP client built in, which will talk to different MCP servers and get the required tooling information. So in this case, your host is your Visual Studio Code application, and your client is your MCP client, which is installed inside your application that you or extension that you installed in that AI application, which is GitHub Copilot. That is your that is maintaining the MCP client. Now that MCP client inside your GitHub Copilot is making connections to MCP servers and getting the list of tools available. So let's say there are different tools. It is able to fetch data sources, APIs, and all those things. So it will get all those toolings information, show all those tools to you when you interact with GitHub Copilot. So that is how this interaction looks like. Now, whenever you type a prompt or whenever you type a query, that host or your uh, GitHub Copilot already has this list of tools that it has access to. Now, when you send a query, it will send a list of tools also available. So now LLM will decide which tool to now call to help users query to get answered. So let's say you have written a query in your GitHub Copilot. I want to fetch the latest candidates created in last 1 month, and you provide a tool like database APIs or database calls APIs, which can give you the database information where the candidates might be or users might be stored. So that way, LLM will get a knowledge that yes, this is the tool that you can call and get the required information also. Now, all this communication happen on the JSON RPC 2.0 protocols. So this is entire communication is done that way as well. Now moving on to let's break down each of these layers separately. Now this is we have broken down into two layers, which is data layer and the transport layer, and then we have the languages which are being used as well. Now, the data layer is on the base of the JSON RPC message structure, and it manages the life cycle also, like the tooling, resources, and prompts. Now, tools we a tool I'll talk about all of these terms one by one. Tools are nothing but the MCP servers that it can give you that what all capabilities that MCP server has. Now, if that MCP server has a capability to interact with external APIs of, let's say, different external vendors or whatever, then it will give you that is one of the tools. Now, resources, what all resources it is exposing, which you can attach directly when you are calling the LLMs for any query. That is about the resources. Now, resources can be any kind of documents, any kind of images, or anything like that, which an MCP server can also expose. Prompts are nothing but the predefined template that it can expose as well. Then the transport layer, how your messages basically flow from your client to server and all that. So for that, we have a there is a server sent events, like when you call to the client. So client will actually send, client will call to the server. So server will send back a server sent response, and client will display based on that. So this is about the different components that it has and how it works as well. Now this is language agnostic, so you can use any language like Python, TypeScript, Java, or anything else to for your development. Now let's look at quickly for a use case. So as we talked about already, one of the use cases, one is the VS Code as an MCP host to multiple MCP servers. So that is about your application. For example, now VS Code is your MCP host, which is connecting to multiple MCP servers also. Then you can enable different AI assistants, which can access diverse data sets also. Now, this is supported by different, uh, I would say, providers like Anthropic, Claude, LangChain, and Microsoft Copilot Studio also. One thing I forgotten to mention in the start, who actually brought this protocol into the market and why it is important. Anthropic is the provider, or Anthropic is the organization that is inventor of Model Context Protocol, and why it is important or why it is beneficial as well. As we saw n into m integration problem, so if you have to build m integrations, so you will have to write a lot of code while interacting with different external services as well. To solve that problem and to speed up the process of agentic processes while being used in the Gen AI, they came up with this approach or as a blueprint, which will actually speed up the creation of the external systems and their adoption as well. This is another reason why it is so important, not only to solve a problem, but rather to extend the adaptation also and extend the community as well. Now, why it is a game changer for AI architects and developers? So there is a unified ecosystem, transforms AI integration from fragmented custom codes to a unified extendable systems and future proof for your systems and all that. So there is a unified ecosystem, as I talked about in the previous minute, that when you are creating or your AI integrations have to be made for the different systems. So you either you write separate integrations for each of your services like APIs, database, or external integrations. You write separate connectors for those. Rather than writing separate connectors, you can create a server which can give you the entire information to the host, and host can see that visibly, and then LLM can decide which one to interact and which one not. Now, on the server side, all these capabilities that you built, like API, database, or external integration, they will have a common pattern of writing the code. They will have a common pattern of sharing the I would say data also when it is talking to MCP client. Okay, so like tooling, resources, prompts, everything is looking like common. So no connector is having their own way of working as well. It's the similar way how when REST API came into the picture and how those were beneficial when we were using them, and how the adaptation of those got speed up with the REST API when different companies used to build the same as well. So this is why MCPs are a game changer, and as at the same time they are uh, required for quick adoption of the Gen AI applications as well. Now we will shift back to one of the architectures that I have built, a very basic architecture to just make you understand how it works, whatever we have talked about in the theory as well. Okay, so now I'm gonna show you what I have a basic representation of how this entire interaction looks like and how it works ideally. So in this small diagram, I've just showcased a basic representation. It is not an advanced use case. So we will give you an advanced use case also in upcoming videos where we will talk about A2As and MCPs separately as well and together as well so that you understand how they work internally. Now there is a user who is interacting with the system. System is nothing but your desktop, for example, or your laptop. And then you have an MCP host, which is nothing but your VS Code or any of the IDE that you use for day-to-day development activities. And then you have an extension, and then you have an MCP clients inside that. So each client talks to one MCP server. So it's a client server architecture as we saw in our PPT as well. So one MCP client will talk to the MCP server which is remotely hosted, or you can host it in your local server also, or in your local file system as well, and you can interact with that also. So that is where the connections are being made. And once the client makes the connection to the server and gets the required tooling, so those tooling information and resources information is passed on to the LLM APIs or the external LLMs to whichever that MCP host is interacting to. So, for example, it is interacting to Chat GPT or Anthropic Claude. So, it will send all that information to the LLMs. And based on that information, the tools, resources that you have shared, so LLM will decide what is the next step for your query to do, whether we should call any tool to get the required information, or the LLM can itself answer more better way for your query. So, LLM will actually decide that, and then it will respond back to you. So now you see, LLM is the core part. LLM is the brain who is deciding what to call and what not to call. But to make it a brain or make it a core engine, it has to have the information so that it can decide where to go and where not to go. So that is where LLMs are pretty important to understand in today's world. So once you understand the LLMs, then the related technologies, the MCPs, agents, agentic AI, A2A, all will come hand in hand and you will be able to understand those pretty easily. So this was about today's video. So in this we have demonstrated you about the MCPs on very high level. So we will bring in some use case also in the upcoming videos so that you get to understand more and you get to apply these concepts more into day-to-day practices. So that's the only expectation. Thank you. If you do like the content, please do like the videos, comment whatever you want to see in the next upcoming videos, and share as well. And if possible, do subscribe to the channel. Lot of people are watching the videos but they are not subscribing, so please suggest us, and if there are any improvements required, or subscribe or like and share the channel. Thank you.